TRS stands for Tropical Revolving Storm. These are storms that originate near the tropics and can have sustained low-level winds in excess of 65 knots. It's the lifespan and sheer size that creates the destructive force of these storms. They can last for weeks on end before decaying and have a diameter of between 300 and 1,500 kilometres. We're now going to examine these storms in more detail. Tropical revolving storms have different names depending on their location. In the Atlantic and Eastern Pacific region, we have hurricanes. In the Indian Ocean, we call them cyclones, and in the Western North Pacific, they are called typhoons. The origins of tropical storms exist in clusters of cumulonimbus clouds that form and develop principally on the eastern sides of oceanic areas. Sometimes linked with the intertropical convergence zone, and occasionally forming on what we call easterly waves, these cloud clusters act as the atmosphere's pump, drawing moist, warm air in at low levels, with a corresponding outflow at the top of the troposphere. These inflows and outflows develop a spiralling motion, the beginnings of the storm. Only around 10% of these cloud clusters go on to produce full-blown storms. Most simply die away fairly quickly. These are the requirements for the formations and sustained development of a tropical revolving storm. The location must be between 5 and 25 degrees of the equator. The sea surface temperature must be at least 26 degrees Celsius to a depth of around 200 to 300 feet. And finally, there must be very little wind shear present, or the storm would be pulled apart. Once formed, the embryonic storm moves westwards with the upper easterly flow at around 15 knots. The warm seas over which they pass act as the initial source of energy. The formation of cloud and precipitation then releases latent heat, which adds more energy to the system as it develops. If the storm is to be maintained, it must remain over the warm ocean, where there is a continued supply of heat and moisture. If the storm tracks too far north, it moves over cooler seas, or if it moves over land, the supply of moisture is cut off. Look at this distribution map of the main tropical storm tracks around the world, and notice how the storms generally follow the peripheries of the subtropical anticyclones. There are distinct stages that can be identified during the development of tropical storms. Let's look at these now. Stage 1 is called the tropical depression. Here we see the first signs of rotation, with a lower central pressure and at least one enclosed isobar. Surface wind speeds will be 20 to 34 knots. Stage 2 is the tropical storm and starts when the system becomes more organised with surface winds of 34 to 64 knots. The storm will now be given a name. These names follow in alphabetical order, alternating between the male and female genders, starting at the beginning of the alphabet with each new storm season in each storm region. Stage 3 is the fully matured hurricane, cyclone or typhoon, depending on your location, and has surface winds in excess of 64 knots. There are several distinctive features of the tropical revolving storm. The eye and the wall are two important ones. The eye, found at the centre of the storm, has a typical diameter of 20 to 50 kilometres, and its tightening is a sign that the storm is intensifying. The eye itself may be cloudless with light winds, and it's here that we find the lowest readings of atmospheric pressure. There is a vertical wall of cloud enclosing the eye, from which bands of cloud spiral out. The strongest winds and most violent weather can be found within this wall. The sector of the wall where this is at its most extreme is where the rotating winds are travelling in the same direction as the storm itself. Flying through tropical storms is possible, but is best avoided. Advisory warnings are given when such storms exist, and satellite and radar images highlight the location of storms clearly. Marked wind shear, severe turbulence, hail and thunderstorms are just some of the many hazards that can be encountered within tropical revolving storms. We have two further depressions to look at in this lesson. Secondary lows are those that form in association with larger polar front depressions, such as we see here. The secondary low will form on the cold front as a small weakness or disturbance. Since it has been spawned within a major depression, it will move with the main cyclonic movement of its parent depression. Sometimes it develops no more than this and dies away. But on occasions, this secondary depression can develop into a major feature itself and will take over as the older main depression fills and dies. The last type of low-pressure system is the tornado. Typically 100 metres in diameter, tornadoes are violent, narrow twists of wind with an intense upcurrent of air at their centre. Tornadoes only last for several minutes to a few hours, much less than other types of depression we have looked at. They are too small to be represented on weather charts, but their effects can be devastating. Winds of over 200 knots have been estimated at their centre. Tornadoes occur in many countries, typically in conjunction with cumulonimbus activity. But the best-known location is across the Midwest of the USA, in the Mississippi region. The initial spin of the air is probably caused by vertical shear, with air feeding into the system from different directions at varying heights. But strong surface heating and great instability are also required for the formation of tornadoes. Most tornadoes occur between 1400 and 2200 hours local time, with a peak at around 1700 hours, and most commonly in spring and early summer. That completes the lesson on depressions. We have examined most of the main types of low-pressure system that occur around the world. That is, apart from the large mid-latitude frontal depressions that are covered in a separate lesson.